Okay, 33 is again. Determine if the matrix is non-singular and find the inverse matrix. Okay, first of all, I need to compute the determinant of the matrix. In this case, multiplication this and multiplication that. This is 12 minus 10 is 2. And 2 of course is different to 0, it's no singular. The matrix, inverse matrix exists. Okay, let's go directly. Remember the cofactor matrix. Cofactor, the shortcut is you put 2, 6, flip it this and this. And flip it this and that is negative 5. And this is negative 2. Okay, it only is valid for 2 by 2 and 3 by 3 is complicated. But after we saw that. Now cofactor transpose is you change is 2, negative 2, and negative 5 and 6. And finally the inverse is divided the cofactor transpose by determinant is 2, and when you divide this 1 is negative 5 over 2 is negative 1 is 3 because it's 6 divided by 2. So you divide by 2 every element. Okay, now this is the answer. Let's do the verification of the multiplication. Multiplication, the original matrix time is inverse in this order. Let's see what happened. Of course, square matrix, the answer is 2 by 2. This is 6 and negative 5. It's obvious as well. Is negative 30 over 2 is negative 15. And this is positive 15. It's 0. Okay, this is 2 and negative 2 is 0 again. And this is negative 5 and plus 6 is 1. The answer is identity matrix of the dimension 2. Let's see in different order. The matrix, the inverse matrix first, and the original matrix second. And again, is 2 by 2, so it's 6 and negative 5 is 1, because negative 5 over 2 times 2 cancel out 2 is negative 5. And this is 5, and this is negative 5 is 0. This is minus 6 plus 6, 2 times 3 is 0 again, and this is negative 5 plus 6 is 1. And again the answer is identity matrix of the dimension 2. Okay? Okay, now the calculated part. The 33 question, of course. The matrix I did before is 6, 5, 2, and 2. And the inverse using the calculator is extremely easy. The only thing you should do is press this key, inverse. And this is the answer. Okay, the answer, but the answer in decimal. If you want to convert as a fraction, you press math, enter twice. And this is the answer. The answer is exactly the same we are doing by hand. 1, negative 5 over 2, negative 1, and 3. Perfect. Okay, 35 again is inverse matrix. 2 by 2 is easy. First of all, find the determinant. 2, 1, AA. This multiplication plus, this multiplication minus. This 2A minus A is 1A. Yeah, I suppose que A, the supposition is different to 0. Okay, it's correct. This is no singular under this supposition. And now, cofactor. Remember, cofactor is you switching this and this, A2, you switching this and this, but change the sign, negative 1 and negative 8. Now, cofactor transpose is change is, for example, this row I change to this column, and this I change to this -2 and 2. And finally, the inverse is divided by A, divided by determinant. The inverse matrix, as always, is a cofactor transpose divided by determinant A. So you divide each element by A. Entonces es A divided by A, 1. -1 over 8, -1 and 2 over 8. As always, we're checking using the multiplication, see if it's true or not. Okay? Let's see. Let me copy again. Let me copy here the inverse matrix. Okay, the inverse matrix is 1, -1 over 8, -1 and 2 over 8. Okay, let's do the multiplication in both directions. Multiplication A times A inverse, okay, it's 1, -1 over A, -1, 2 over A. Well, the answer is, of course, square matrix. 2 by 2 is 2 times 1 is 2. This multiplied by this, and -1. It's obvious this one. This multiplied by this, this multiplied by this is -2A, and this is positive 2A. Is 0. Okay, this time this is A, this time this is minus A, again is 0. And this time this is -1, and this time this is positive 2. The answer is 1. Again is 1, 0, 0, 1, que es identity matrix of the dimension 2. Okay, let's do it in the different order. 1, -1 over A. No. Make it correct. Okay. Is -1 and 2 over A times 2, 1, A. Is multiply this times this. Is 2 minus 1, obviously it's 1. This times this is -1, no, 1, and -1 is 0. And this time this is -2 plus 2, because it's 2A times A is positive 2, is 0 again. And finally, this is -1 and plus 2 is 1. Again, the answer is identity matrix of the dimension 2.